December 19th is the critical date when the interstellar object 3I Atlas makes its closest approach to Earth at 1.8 astronomical units, and the data coming in right now implies we are looking at something that defies the standard physics of our solar system. We are seeing 5 distinct anomalies that suggest this is not just a rock, but potentially a functional object, and we need to break down exactly what to expect when it swings by. The first and most immediate anomaly that you need to know about is the visual evidence from the Hubble Space Telescope captured on November 30th. Hubble detected a distinct and persistent anti-tail, which is a spike of material pointing directly at the Sun. In standard comet physics, an anti-tail is usually an optical illusion caused by the Earth crossing the comet's orbital plane, where heavy dust particles seem to point sunward due to perspective. However, the geometry of 3I Atlas does not fit this explanation because the spike is too sharp and too consistent. Avi Loeb and other astrophysicists have noted that this feature remains oriented toward the Sun, regardless of the object's tumbling or trajectory, which mimics the behavior of a stabilized structure. If this were a natural rock, the solar wind should be blowing all gas and dust away from the Sun into a single diffuse tail, but instead we see 2 distinct jets. One is the standard smoky tail we expect from outgassing, but the second is this sunward lance that looks suspiciously like an exhaust plume or a counterflow designed to keep the object oriented. This brings us to the second and perhaps most alarming anomaly, which is the chemical composition detected by the ALMA Observatory in Chile. Spectroscopic analysis has revealed that the cloud surrounding 3I Atlas contains massive amounts of methanol and hydrogen cyanide. While hydrogen cyanide sounds terrifying because it is a deadly poison to humans, in the context of astrobiology, it is a critical building block for amino acids and the bases of DNA like adenine. Methanol is equally important as a fundamental ingredient for biological chemistry. The smoking gun here is not the presence of these chemicals, but the ratio. We are observing a methanol to hydrogen cyanide ratio of 124:1, which is a chemical signature we have almost never seen in comets native to our solar system. This has given rise to the Friendly Gardener hypothesis, which suggests that if you were to design a probe to seed a barren planet, with the necessary ingredients for life, you would load it with exactly this cocktail. We are watching a celestial crop duster pass by Earth, and the high concentration of these specific molecules suggests a manufactured payload rather than a random geological accident. If the anti-tail is a nozzle, then it's currently spraying this biological starter kit directly into our orbital neighbourhood. The third anomaly is the colour shift, which has moved from red to green, and is now settling into a deep electric blue. When interstellar objects enter our system, they are usually dark red due to millions of years of exposure to cosmic rays, which bake the surface into a carbon-rich crust. 3I Atlas started red, but as it approached the Sun it turned green due to burning diatomic carbon, which is rare but natural. However, as it now speeds away from the Sun and retreats into the cold of deep space, it should be fading back to a dull red or grey. Instead, it has shifted to blue. In astrophysics, blue light indicates high energy or ionized gases typically associated with extreme heat or high-velocity impacts. Since the object is moving away from the heat source of the Sun, this persistent blue glow is inexplicable unless there is an internal energy source maintaining the reaction. Some theories suggest we are seeing the exposure of fresh, pristine ice from the core, but the intensity of the blue spectrum has led to speculation about propulsion byproducts or ionized exhaust from a drive plume. The fourth anomaly is the signal detected by the Meerkat radio telescope at a frequency of 1665 MHz. Natural comets do emit radio waves, but they are usually chaotic bursts caused by the violent fracturing of the nucleus or the sudden release of gas pockets as the object rotates. The signal from 3I Atlas is different because it is a steady, continuous hum. A steady signal in radio astronomy is the hallmark of a stable emitter or a carrier wave rather than a random natural event. If this object is artificial, a steady hum is exactly what you would expect from a system in standby mode or a propulsion drive operating at a constant thrust. This connects directly to the fifth anomaly, which is the debris field. A new research paper analysing the dust trail indicates that 3I Atlas is not just shedding fine particulate matter like smoke, but is dropping heavy pebbles and gravel. This distinction is crucial because fine dust is easily blown out of the solar system, by the pressure of solar radiation, meaning it disappears quickly. Heavy pebbles, however, are not affected by solar pressure in the same way, and they settle into stable orbits. This supports the seeding theory, because if you want to leave a message or a biological package in a star system, you do not use fine dust that blows away, you use heavy capsules that stay. We are potentially looking at a message-in-a-bottle scenario, where the bottle isn't the object itself, but the millions of heavy particles it is leaving behind in our path. The final piece of the puzzle is the trajectory. 3I Atlas is on a hyperbolic orbit moving at 30 kilometers per second relative to the Sun, which means it is moving too fast to be captured by the Sun's gravity. It is strictly a visitor. It is currently on an escape trajectory that will take it past the orbit of Jupiter by March 2026 and out of the solar system entirely by the 2030s. This behavior fits the scout theory perfectly. If you send a probe to map a star system or test its defenses, you do not stop to land on the White House lawn because that exposes you to risk. Instead, you perform a high-speed flyby, mapping the terrain, dropping your sensors or seeds, and using the star's gravity to sling you to the next destination. The fact that 3I Atlas survived a perihelion approach to the Sun that should have torn a loose pile of rubble apart suggests it has significant structural integrity. On December 19th, the object will be illuminated from the side relative to Earth, giving us a unique opportunity to peer through the thinning gas of the coma. Telescopes like James Webb and Hubble will be looking for the shadow of the nucleus. If we see a jagged irregular rock, it might just be the strangest comet in history, but if we see a smooth shape or a cylinder, or if the blue glow intensifies as it aligns for its departure burn, then we will have our answer. The combination of the stabilized anti-tail, the specific life-enabling chemical payload, the impossible blue shift, the steady radio hum, and the heavy debris field makes this the most statistically improbable natural event we have ever witnessed. We are about to have our close encounter, and even though it is 269 million kilometers away, that is point-blank range for a civilization capable of interstellar travel. Make sure you are subscribed, because as the data from the December 19th flyby comes in, I will be breaking it down immediately to see if the shell finally cracks and reveals what is hiding inside the blue cloud.